Hi, I'm Sam. Welcome to the Moralis channel. Today we're going to look at the SimCity Web3 sample game that I created using the Moralis Web3 Unity SDK. Here's our game, SimCity Web3, running inside Unity. From the main menu, we can authenticate the users and know that they're logged in. There's a settings scene, which allows for some settings that are game specific. Inside the map itself, you're able to browse around by scrolling. You can zoom in and out with the mouse wheel or the buttons. Recenter the screen back to where it started, next to this green marker that indicates the center point. And you can use the plus and minus keys to add and remove properties. Each one is an operation happening on the blockchain. Here, properties are stored as NFTs, and the metadata included shows the latitude and longitude for the property, so it knows where to place itself on the map when it's loaded. Hi, my name's Sam. I'm a Unity certified developer at Moralis. I have over 20 years game dev experience and more than 10 years experience as a digital nomad. I love spending time in nature and practicing sports, as well as drawing, painting, and making music. Moralis offers the Web3 Unity SDK. Let's break that down. Moralis helps you build Web3 applications. It supports Unity, which is a fantastic platform for creating gaming experiences. And the Web3 Unity SDK helps you bring Moralis technology into your Unity projects. Let's compare the different generations of the web. We're currently departing Web 2 and seeing more and more Web3 experiences. Now, it's not a perfect analogy, but let's look at the generations in games. With Web3 technologies like Moralis, combined with a popular game engine like Unity, we're able to rapidly develop new experiences, ones that could not have existed before. With Moralis, you'll see that Web3 game development is powerful, practical, and profitable. With Moralis, developers move faster from idea to market. Moralis includes complete learning resources, including sample games like the one we're looking at today. Each Unity sample game is a complete experience. For additional information about Moralis and Web3, here's some suggested links to take a look at before moving forward. The Moralis Web3 Unity SDK Overview. Handling authentication from your game project. And the Examples project for the Moralis Web3 Unity SDK. This goes scene by scene and shows different features and highlights for Moralis. The SimCity Web3 sample game. Many sample games, like this one that we're talking about today, are available on our GitHub, and it includes the Moralis Web3 SDK. When you open up a sample project inside Unity, first take a look at the README. Follow the steps, and enjoy. A suggested approach for how to use these projects is to first play with it as a game player inside Unity, and then dig around in the code, see which concepts you want to learn about and experiment with, and which ones you want to port over to your project. Some highlights in the project structure to take a look at are the README, the scenes, and different scripts. The SimCity Web3 singleton is a great place to get started. It's the main entry point for the game's code. The main scenes of the project are the intro, authentication, the settings, and then the game itself. The structure in each of those scenes is pretty similar, at least from the high level. There's a world game object that hides the complexity of the camera and lighting for the scene, maybe some other objects there. And then there's another game object that has the same name as the scene itself, and that's the core amount of behavior you want to take a look at first to understand how that scene operates. The game handles authentication automatically. Now, a note, not all Moralis features require authentication, but for simplicity's sake, the game requires authentication before getting into any gameplay. The Polygon blockchain. Now, we know Moralis is cross-platform and supports platforms like Unity, but it's also cross-chain. Well, what is Polygon? Polygon is a decentralized Ethereum platform, and it's good for building scalable, user-friendly dApps. Some of the key features are that it has low transaction fees and high security. So why use Polygon? Well, all blockchain transactions require gas fees. Developing dApps on the mainnet is expensive because you literally need to pay those fees. However, developing dApps on testnets is completely free. So what's a Polygon faucet? Well, a faucet is a piece of software that helps you put currency onto your blockchain account. The steps that we'll use here are get a MetaMask wallet, add the Mumbai testnet, and get the Matic tokens. Let's see those steps in detail. First, we can go to the MetaMask website and get the Chrome extension. You can also connect that to your mobile wallet. Then you add the Mumbai testnet to your wallet. You do that by going to the admin at the Moralis website. And finally, to get the Matic tokens, you're going to visit the faucet itself, open up your MetaMask, and be able to do the transfer there. The transfer is free and takes just a couple minutes. And you'll only need to run to this website once or twice during your development. You'll have enough currency there to do all the transactions that you need. NFTs in gaming. Our game is going to use NFTs to represent each property that exists on the map. An NFT is a globally unique asset that you can use inside your game. Here, because the game is about buying, selling, creating, and destroying properties on a map, each property will be represented as an NFT, and that will be on the blockchain. Now, when we mint an NFT for our property, and when we load them after the fact, we're going to need to have some metadata that exists in that NFT so we know more information about the in-game property itself. For this game, it's pretty simple. We're going to store the latitude and longitude, which are mapping information for where it should exist in the mapping world. We have a couple of options for how we could store that. We could store it off-chain, where the NFT itself knows about a URL, and that URL can load JSON from somewhere, an image, or whatever data that you need. This is a traditional approach for production projects. A second approach is an on-chain NFT. This is where we hide the info that we want in the NFT itself. Now, with that off-chain NFT, there is a piece of metadata, and that metadata is just the URL where the game can find the rest of the information. This could be a JSON file, for example, that contains tons of different information that the game could load separately. This takes one call for sending or creating the NFT, and every time you fetch, it would require 2 calls. More or less, it depends on how your game is set up, but the first call would be to get the NFT itself, including that URL, and then you would do a second call to the URL to load the JSON. With the on-chain approach, instead of the URL, we're just going to pack some information into a simple string. In our case, it's going to be longitude and latitude, but you could imagine different scenarios for a simple game. You are restricted with how long that character string length could be, so you can't store endless amount of information. But for the simplicity of our game today, since our data set is small and we want to load everything with just one call, we're going to do this approach. The NFT workflow is to write a contract, deploy the contract, mint the NFT from Unity, and then get the NFT into Unity, which is loading our properties that have already been minted. Let's take a look at that in detail. So for writing the contract, you can do that from scratch using various standards. We're going to be writing it in Solidity, which is the language that's required for all the contracts on the Polygon network. Included in the repo is a smart contracts folder where you can see the final version of each of the contracts that I'll use. If you get lost along the way or you want some help in how you create your contracts, you can look at that folder for reference. There's many popular ways to deploy a contract onto the Polygon blockchain. The one we'll use is called Hardhat. Then from within the Unity, using C# and the SDK provided by Moralis, we're able to mint the NFT. This is going to happen each time the user wants to buy or create an in-game property. Then to get the NFTs, we can use the Moralis SDK inside Unity and load all the NFTs that are in our gaming ecosystem. This includes all the ones that we've created or any theoretical other players inside your game have also created. Project setup. For this and any project, there's some steps to get started. First, we're going to set up the admin. Then we're going to copy some configuration values that we're going to use later. We'll open up Unity and get Unity started, and then paste those configuration values in. This way your Unity client project knows which server from Moralis it relates to. In the admin, you're going to create a new dApp. You'll select the environment and select the network. Select the region, give your dApp a name, copy the configuration, create a Unity project, I typically use the latest public release, and you can use any of the major templates that Unity provides. Import the Web3 Unity SDK into your project. You can do that at docs.moralis.io. And inside Unity, open up the Web3 setup and paste in the configuration from the admin. Now that we're set up, let's take a look at the specifics of the SimCity Web3 game itself. So this is a game that will allow us to explore a map and add and remove properties from that map. Each property is represented as a simple house in this demo, but you'd imagine a larger project could allow you to choose different properties of different sizes, place them all around the world. This game showcases some key Unity features. And the game showcases many Moralis features as well. Web3 projects require a certain number of accounts for development. Now, of course, the end project would be played potentially by many, many different players. But for simplicity of development and particularly debugging, in this project it's helpful to have 2 user accounts. Each of them would be set up in MetaMask and would allow you to play against yourself, so to speak, to make sure that the project works well. We're going to need at least 2 accounts here. One that you would log in for the development, including the Hardhat deployment, and the second one, which would be you as the game player. Now, you could theoretically use less than this, but this is a good strategy to make sure that your permissions are set and that the game runs well. Project status. At the starting point of this video here, much of the work is already done. Let's review where we're at. In project planning, we decide what we will create. Now here we know it's going to be a mapping game about buying and selling properties, and we're going to choose the technology involved. In the design phase, we decide how we're going to create it and what it's going to look like. So we know we're using Unity, Moralis, and the Polygon network. In the development phase for Unity, we've already set up most of the core gameplay. We've got buying and selling properties working with the Moralis database, but not yet with contracts. And we've play-tested the project with success inside the Unity editor. Together, we'll start with the development of Web3. Let's define what our needs are, set up the contract in Hardhat, configuring it, loading it in using Unity, and then finishing up the development inside Unity as well. And after development is the deployment. This is where you share your project with other people. Now, for the sake of this sample project, I'm releasing it for free for you to download and check out. You can learn from it. I'm shooting this video, of course, on top of it. Deployment is also a typical stage in production where you would release the game into the wild, perhaps on different app stores around for users to play it for free or for pay, however you decide. The project to do. So now that the traditional game is set up and ready for us, let's discuss how we're going to add Web3 technology. First, we're going to define the needs of the project, set up the contract, integrate the contract, and then finish up development. For defining the needs, the project has a very light version of the model view controller service architecture. This takes the responsibilities of a typical game and it divides it up into 4 different sections. In our implementation, there's 1 class for each of them. And we can take a deeper look at how the service layer works. This is what's going to communicate through Moralis to get the external data that we need. So this game is operable in either database mode or contract mode. The database mode is done for you, and the game is playable there as a starting point. When you toggle over to the contract mode, which we'll do together in the live coding section, you'll see that that area doesn't yet function. You can always toggle back to the database mode if you want to see it functional so that you can experience the game and then come back to developing the contract version to make sure that what you're doing is on par with the plan. To set up this toggle between the 2 modes, I use what's called a factory. This is a simple snippet of code that just says, if we're in contract mode, do the contract stuff. If we're in database mode, do the database. For live coding, let's take a look at Hardhat. Let's take a look at how we'll integrate that contract into Unity. And let's finish up the development inside Unity. I'll begin the live coding. So that you can see the screen best, I'm going to lower the opacity. Let's take a look at what I've set up already. So I have Unity installed. I've set up Node.js as well, just by following the link and clicking download. I've set up MetaMask as covered earlier, and installed Visual Studio, which is a free code editor. You can use any one you want, but that's what I'm going to use today for the contracts. Let's begin by taking a look at one of the instructions files that comes in the repo. So let's get the repo. Here's the project available on GitHub. You can download the project or clone it here. I created an empty folder on my desktop, and I've dragged in a couple key positions within the repo that are going to be useful for when we're creating our contract here. First of all, in the documentation of the repo itself, there's a smart contracts folder with some Hardhat specific files. This represents the end result we're going to go for. And we're going to begin with just the instructions, and we'll follow those instructions along. So I'm going to point Visual Studio to a new empty folder here. Let's create one called Hardhat Start. And I'll paste in that instructions file that we got from the repo. Let's open this up in Visual Studio. I'm going to open the folder to the folder that we just talked about. Here we are. We're in the Hardhat Start folder, and I've got that instructions. Let's take a look at those instructions first. So here I'm going to scroll down just to take a look at the size and volume of the steps we're going to go through. Now let's take a look at the top here. So on the left, I've got the Explorer where I can take a look at the different folders. Here, the only one we're going to start with is this instructions file. So the complete Unity game is in the repo here, and we can create and deploy the contracts within Visual Studio here. This is a separate additional step that's done outside of Unity, and this is the part where we're bridging the Unity world into the blockchain by creating contracts and deploying them onto the blockchain. We're using Hardhat. So let's just follow through the steps here. First thing is installing Node.js if you don't have it already. I've done that. Now we're going to create an empty folder outside of Git and open it up in a text editor. That's the steps we've just done. Now, the reason you want to do it outside of Git is that by default, what would happen if you were to work inside is you'd get a lot of Hardhat specific files that would be in Git and committed to your repo. You may not want that. In some advanced workflows, that could be perfect, but for us, we're just going to put it on the desktop and be able to work from there. So we're going to open up a terminal here with new terminal. And now let's start with those steps. So I'm going to go ahead and use npm i. This is going to install the Hardhat to the local file system. We'll continue with step 3. We'll hit enter. Now Hardhat is installed. You can see the folder structure on the sidebar there shows some more files have been added in the folder that we're pointed to. Those are the ones that are going to help us use Hardhat operations on the command line. Now in step 4, we'll install some additional dependencies. Now that we've finished step 4, let's take a look at some of the files that we've got. We have a contracts folder, we have a scripts folder, and we have a config file. Now there's certainly some other files involved there, but we're going to start taking a look at each of these. So the general flow here is we're going to be writing a contract in the contracts folder. Then we're going to be using a script in the scripts folder to deploy that contract from our local machine onto the blockchain. And the other files are going to help support us there. The general flow here is that you write a contract, you deploy it to the blockchain. At that point, you adjust the Unity project slightly so it knows where to look for that new contract, and you continue to Unity development. Periodically during development, you may need to edit or add to the contract. You step back here, edit the contract, redeploy it, adjust Unity again so it knows how to point to the newest instance online, and you'd repeat that flow. In this case, we've got a few different public methods we're going to call, and Unity should have no problem reaching those. So our development is pretty straightforward, but we'll take a look at the details. Let's look at the next steps in the instructions. Between 5 and 10, we're going to be making small changes to those existing boilerplate files that we saw and went over on the sidebar. Optionally, you can reach into the folder that's provided in the repo and pull out the complete project files. Let's go over the complete project files. Here in the documentation, under smart contracts, we have similar folders that we saw before in Visual Studio. We have contracts, scripts, and then in the main folder here, we have the Hardhat config. Now, because I've opened these in Unity, there's also a meta file next to each file. The meta files aren't needed here, so I'm going to select the core files themselves and move them into Visual Studio. Now, whether you followed along all the instruction steps or copy and pasted from the repo, this would be your end result. Let's take a look at each of these files close up. So here in the property contract, we're extending an existing contract that is the ERC721 standard with URI storage. This is allowing us to do either the on-chain or off-chain storage. What we're going to do, instead of passing a URL that holds all of our metadata, we're just going to use the string itself of the URL to hold some pieces of data for us. In our case, it's going to be the latitude and longitude for each property. And each property that is owned in-game is going to be a minted version of this contract. This is the only contract that we need in our game. Let's take a look at some of the sections within. Most of this is boilerplate and comes with the contract, but we're going to need to count up a unique number from all of the IDs for our minted properties. So if at one point we have 10 properties in the entire ecosystem, we would have counted up from 1 to 10 here. This way the contract can keep track of all of the deployed NFTs. We're going to hold a reference to the owner of this contract. In the constructor, we'll give this contract its name of property and a token symbol. Here in mint property NFT, we're going to take in the URI, which is typically the URL where the storage would take place. However, this incoming string is just going to be our latitude and our longitude concatenated into one string. Now inside, this is pretty standard ER721 stuff, but what we're going to do is just increment that counter, mint our NFT, put that metadata that I mentioned in using set token URI for storage, then increment those IDs so the very next time this is called, it properly has a higher number for the next NFT, and then we'll return the item ID for this particular item. For the burn property NFT, what we're going to do in-game is be able to select a property and click the delete or the sell button. Now we're not earning any currency or spending any currency due to the simplicity of this game. So when the game refers to buying and selling properties, really we're just minting an NFT and then burning that NFT. So here in the burn property NFT, we're going to pass in the token ID for the specific one NFT that has been minted previously that we want to burn. Then inside, we're going to call burn token ID. This is some available existing functionality that this contract supports. And lastly, in burn property NFTs with an S at the end, we're going to be able to pass in an array so that from our in-game settings menu, when we want to clear all the data, it will loop through, collect all the token IDs for the properties that are on our map, and be able to do all the burning in one pass. Now, this is better than calling the previous method multiple times in a row. Here, simply one contract call does all of the deletions. Now, something to be said here around creating and destroying NFTs is there's definitely security implications that you would want to have in a production environment, including but not limited to controlling which owning address is able to do those operations. Now, notice here in the code, I have a disclaimer that we've commented out those kinds of security precautions. You may even want to have much more than what's commented out here. So just in your own development environment, this is a very cheap and easy way to allow for flexible calling of these methods, but this is in no way fit for production. Now let's take a look at the deploy property script. After reviewing these scripts, we'll go ahead and call them to do the actual deploy, but let's take a look at the source code first. First, in the deployment, that's where Hardhat does the heavy lifting here to take your contract and deploy it onto the Polygon network. For the use of this game and this tutorial, I've added a custom bit here, which is going to format in text some output, which is going to be an easy copy and paste from the deployment into our Unity. We'll do that together after deploying. Here we're going to do some waiting before the next step. And here we're going to verify the results. This is going to check with a scan website to be sure that this has been properly deployed. We can also go into the browser ourselves and see those results. And finally, we'll have verification completed. At this point, we're ready to develop immediately from the Unity. We should be able to call our contract with success at this point. And here is the nearly complete config file. In the configuration section, there's some values that you need to set on your end. For security and privacy concerns, I have not populated these 3 string values, but you'll need to get them yourself. From MetaMask after you sign in, from admin moralis.io after you sign into that website with your own credentials, and finally, you'll go to polyscan.com. This is going to help us with that verification. You'll create a free account, and after signing in, you'll be able to paste in that info there. Now that our contract is ready and the supporting files are done, let's go forward and do the clean, compilation, and deployment. We'll follow the steps here. First, we clean. Then we compile. And then we deploy. I'll make the screen larger here so we can see the results. So here's where I ran the deploy. Let's take a look at what came in the results. We have the address of the deployed contract, which Unity needs to know, and we have the ABI of the contract. This is needed for Unity so it knows how to call the contract. Then after the waiting, which we prescribed before verification, we can follow the verification result link and see our contract living on the blockchain. Here's lots of information about our deployed contract. The most interesting thing is the address itself, which we can copy from the top. And if we scroll down, the ABI is available here. We can copy that to the clipboard. However, our deployment script gives us those 2 values here, so we're ready to go. We'll do some development in Unity, and we'll return to these values and how they're going to be used in Unity a little bit later. So to recap, where we're going to start here is we've gone to the GitHub and pulled the project down onto our local machine. We've got Unity set up, and we've opened the project in Unity. Here inside Unity, we'll start by opening the README. The README has everything that you need to get started within Unity. So let's see. We have already set up our admin at this point. We've gone to the Unity setup window and pasted those configuration details from the admin in here. Let's take a look at this configuration file that is specific to this game. So here we see several things that within this project, but specific to the game, not necessarily Moralis, we have some values set. So we're going to link to different scenes, so these scenes know how to load each other. And we've also got a very important setting here for the service type. Now, when it's set to database, this game is fully operational and uses Moralis's Moralis object and database functionality. I started to develop the game that way as an easier, quicker way to get the features complete. This includes persistence, that if you open and close the app, it is loading from a database, not anything that's just in memory. So it's a great way to get started. You don't necessarily have to do it for your project. You could go right to the Web3 contracts, but that's what I've done here. And that's our starting point. So with database selected, let's take a look at the game. But first, let's keep looking at the README. So continuing with it, we've looked at the configuration asset and we've set database there, so we're in the right mode to get started. Now let's add the example scenes to the build settings. Now, because this project has multiple scenes, the intro, the game, the settings, etc., Unity needs to know about all of them. So this is an easy way to just add them there. We'll go ahead and click that. And if we were to check the console here, we see that it properly added 4 scenes, so that's good. Then down here, you can choose your own layout if you like to organize the way Unity is, but for consistency in this video, if you want to follow along exactly, you can load this example layout. So just clicking that refreshes the screen. Now for setting up the Web3 contracts, we include the Smart Contracts folder and the instructions text. If you want an easy way to get at that, you can click that here. And then to get started by playing the Unity experience, we're going to go ahead and click this first scene and then hit play. All right, so here we're going to authenticate. You can use any Wallet Connect compatible mobile. I'm going to use MetaMask mobile, and I'm pointing it right at the code. I've signed in there, now we're logged in. You'll notice that when I stop and start Unity, it respects the authorization. That auth session will stay open for days or more. So let's take a look at what we can do next. We can go into the settings here. We can reset any data. This removes any properties from the map if we have them. It's grayed out because we haven't created any yet. And let's view the map. So the map loads up. It loads any properties. There are none. You can use mouse wheel to zoom in and out, look at different places in the world. You can hit the recenter button to bring you back. This is set to Manhattan just for fun. You can zoom in and zoom out. And let's choose where we want to hit plus to add a property and minus to remove it. So let's go plus, choose to put it right on this little island here. It's going to save that to the database. We can step out of and come back to the map just to confirm that it did indeed store. So there it is. And let's create another one. Let's choose one of them or the other one of them and delete it. And we'll create one more just for test. And go to the settings here and hit reset all data. And now back at the game, we've got none. So what we have here is feature complete for database. Now what we want to do is toggle on the contract mode, and then together we'll code how to make that contract happen. So the configuration here, we're going to toggle over to contract. Let's take a look at some of the key classes. So under scripts runtime, the most important classes are here on the outside and easy to get. There's the singleton, which is the main entry point for most of the game code. There's a helper function, which does some reusable functionality. And there's a constants file, which has different hard-coded values, which you might want to tweak. We've already seen the configuration file, which is what lets us toggle some high-level configuration. In this case, going from database to contract. We're already set to contract. Now, under service here, this is what we're going to take a look at. There is a complete contract service that runs and is feature complete. There is a video start version of that, which we're going to start with here, which is the same structure, but without the code. We'll code along. There's the database service, which sits here complete. We're not going to touch that one, but you can feel free to dig into it if you want to look at how Moralis Objects and Moralis Database works. And then there's a service factory. Let's take a look at that so we understand the main concept here. So when the project is deciding which type of service class, either one that's going to reach externally to the database or one that's going to reach externally to the contracts, this is the functionality here. When we toggle that dropdown that's inside the config, it will just set it either to database or contract here, and then choose the appropriate class. So we're going to do all of our coding inside the contract service class. First, I'll take that start file and rename it so that's our new starting point. So I'll delete the old one. I'll just rename this without the .video start. I'll go inside of it and remove the comments. So let's go over the contract service. There'll be a couple other classes we'll look at along the way, but this is where we're going to focus our efforts. So in the constructor, what we do is create a new property contract. This is a custom C# class, and we'll take a look at that in a moment. Here's some of the methods that we will populate. There will be load property data's async. This is what's going to call for the NFTs out there and bring them in and represent them on the map. We have save property data async. This is what's going to happen when we want to add a property using the UI and then have it saved to the contract itself. Then we have two deletes here. We got one to delete exactly one property. We'll use that in the game when we select a property and click minus to sell it or delete it. And then from that settings menu, we're going to want to be able to delete all the properties in the project. So the second version here is delete all property datas with an S, and that will burn all the NFTs. So let's get started and fill this out. First, we're going to take a look at that property contract class. So property contract allows us to take the values we got from deploying via Hardhat, the ABI and the address, and paste them in here. This is the only place in the code that you need to update because we only have one contract that gets deployed. If you had multiple projects, you might have to juggle a few versions of these values, perhaps in different spots in your code. But we've got exactly one deployed contract, so that's all we need to do here. We'll paste in that address and ABI in a moment. Then we see we've got a method to mint the property, to burn the property, and to burn multiple properties. So that's the needs that we saw from the last project. Now, the property contract extends contract. Let's take a look at that custom class that comes with this game. Now, this could be used for any type of contract. For each, when you want a subclass to make a property contract, you could subclass it to make a game save contract, as long as it fits the basic structure of what we've deployed on the blockchain. So let's take a look at this. So it just holds that address and ABI value, easy and reusable, and then it calls a wrapper around execute contract function. So down here at the bottom, we can see that we're calling Moralis execute contract function. The rest of the stuff around it is some debugging values that if we want to toggle them on, we can see exactly what's getting sent here and there. We have this isLogging bool, which makes it easier for us to call that Moralis function with lots of logging if we need to, and that's very helpful while we're debugging. And that's it. That's the rest of this. So let's go back to the property contract and take the values that we got from our Hardhat and paste them in. So here we are back in our Hardhat. Let's copy these two values that we need for our Unity project. We simply paste them right in and save that file. Now that the property contract is set up, let's go in and look at the service. We'll code each of the methods that we need here. So for the load property datas, we're going to check that the Moralis system status is where we want it to be. Then we're going to get the NFT info. We'll populate the return value, and then we'll pass it back. So we've already got a list of property datas ready to go, but that list is not populated yet. So let's take care of this. The first thing that we do here is we check to make sure that Moralis has a user. This makes sure that we are authed and logged in. Now, we have a flow in the app that from the main menu, you visit auth before the buttons allow you to enter the game. So there's some protection in there from the UI layer where you can't, as the user, get into an area that you shouldn't. But it's a good best practice here to make sure. Also, this particular NFT method call that we're going to do requires that we have a user set up. So we're just double checking here to make sure that the state is right. Next, we'll use the Moralis API to get the NFT owners. We pass in the contract address using the values that we pasted in from Hardhat there. And then we make sure that we check the chain list for Mumbai, which is the Polygon testnet that we deployed to. This will return a list of all of the NFT owners for any NFTs that are compatible on this particular contract. So when we first run this, because we in our own ecosystem here have not created NFTs, we would expect to find 0 results. But once we code the other methods, this is going to be what helps us verify that we did indeed mint and we did indeed burn. So this is a great place to start. Now to populate the return value here, we're going to loop through those NFT owners. And for each of them, we're going to create a new property data. Property data is a custom class that's inside this project that defines one particular property that's sitting out there on the map. You can see that it's created using 3 things. First, who is the owner? Then what is the ID string for the actual token? And then what metadata comes along. Now that metadata, you can see it's the token URI that we're passing in there. Because remember, we have this concept of an on-chain NFT where we're using the token URI to hold the latitude and longitude for the position. In other types of projects, that would be a URI or in other words, a URL that would point to maybe somewhere online to be called to fetch additional info. But we're just storing latitude and longitude as a string. And then finally, we'd return that value from the method. So this method here, which is the load property data's async, is now complete. Now, probably the first thing that we'll do as testing out this as a user would be to go to the map and hit plus to add a property. That's going to save a property through using this method here. So let's populate this one next. The steps that we're going to do here are minting the NFT and then updating the return value we're going to pass back and then finally returning it. So to mint the NFT, we're going to call a custom method on the property contract, which is going to mint the property. We'll take a look at how that method works after we finish up what we're doing here. When we mint that NFT, we get back the new token ID string. Now, what's useful here is we want to store that value in the property data so that the map item itself knows which one of the IDs it is so that it can delete itself. So there's lots of different ways that we could have done this, but I just choose to recreate the property data and pass it back from this method. So you imagine we have a new item that's created on the map, and then we go to save it, and that item just gets replaced with a version with a little bit more data in it so that it could be deleted at a later date. That token ID string is used for that. So with that in there, that save property method is now complete. Now when we choose a property on the map and then we hit the minus button or we choose to delete it, it's going to call the delete property data async method here. So we're going to populate that next so that we can test out how we would be able to burn these NFTs or remove them from the map. Quite simply here, we're going to call a custom method. We'll take a look at that in a moment. And that's going to burn our NFTs. And lastly, from the settings menu, while this is really for development only, you wouldn't imagine a game would allow you to delete all the properties in the entire ecosystem from a button within the UI. So this is not a secure nor production ready feature, but for development, it's very useful at runtime to be able to go in, create some properties, and then easily delete them all, just so you can test out to see that your current features or future features are working the way you'd expect. So inside that settings menu, we delete all the properties, and that's done here. And that's just calling another custom method within. Notice a slight distinction here. This method has NFTs, so it's a plural. It's going to be deleting a list of property data. So let's look at the 3 custom methods that we've used here. We've used mint property NFT. We've used burn property NFT, and the one that is for a list, burn properties, burn NFTs. So let's take a look at each of those. So inside the mint property NFT async, we're going to get the metadata for that specific property, and we're going to call the Moralis execute contract function. This string that we pass in, which we see here is mint property NFT, it's important that that match exactly the method name, including the case sensitivity of our Solidity contract method. Assuming that that's done properly and that you pass the right info, in this case the metadata, it will get called and asynchronously we'll get the result back. Let's double check how that get metadata is formed. So here inside the property data, which we have not taken a close look at yet, it just concatenates one string that has the latitude and then a pipe symbol and then the longitude. And down here, when we create things later from that, it's just going to strip that string into two and be able to know the latitude and longitude. So this is a very helpful and simple way to just put the important info in one string, store that on the NFT, and then be able to split that info when it comes back in. Now let's look at how the burn works. So remember, when we're burning, we're passing in the property data. What we do is we get the token ID, which refers to the contract token ID for that specific NFT. This is the one that will be burnt. Then down here, we call execute contract function, and we pass in again the string literal that has to match exactly to our method that is on the Solidity side. And lastly, in the burn property NFTs with a plural, we pass in a list of property data. We're basically doing the same thing that we saw previously, but here we're just iterating through a loop. We're generating a list of token IDs, and then the Solidity contract expects the arguments to come in with a list of token IDs. So that's all we're doing here. So let's imagine a different type of game where we could shift select 3 properties. It would build a shorter array that contains just the 3 properties that we're deleting. But in this game, you either delete the one that you're selecting or you delete them all. And it's the all here that is handled here in this burn. So now let's run the game and let's run it in contract mode and see how it goes. So back in Unity, remember how we want to toggle. We're going to use the config and we're going to set that type to be contract. And now we'll set it to contract. We're going to run the game. Now we're already logged in from our previous session of doing the database version, so that's okay. And we're going to go ahead and we're going to go to the settings. We see that reset all data is properly grayed out because we have not yet created any properties. And now we'll go to view the map. We'll explore the map a little bit. We see that we have no properties, which is correct. We have not yet created any. Now let's hit plus and add our first property. I'll put it on this little island here. Now a note on the flow here. I clicked plus and then accepted in the UI. That's when we call the mint. Because that is a public method on our Solidity contract, there's going to be a signing operation required by our mobile phone. So a user playing this type of game would need to have their phone next to them and be able to sign these operations. Depending on how you set up the game, these signed operations and the need for the phone could be once a minute or once an hour or once a week. It quite depends on how you structure your game. But for this simple example, each key thing that I do here, I need to click verify on the phone. An alternative would be building this project for WebGL and deploying it to the Chrome browser. Then you would use MetaMask in your browser to do this, and in some ways it could be a bit easier. But for this development, we're just using the Unity editor for deployment, and we're using the mobile phone to do the signing. So let's check that that worked for us. We'll step out of the scene here, and here in settings we see that the reset all data button is active, meaning the game thinks there's some properties, which makes sense to us because we just created one. Let's go back into the view, confirm that it's there, and then see about deleting something. So here in the view, we can go over here and see the map. There's our created property. Let's create another one. We'll choose to put it on this other little island. And here we see both of the properties here. Let's delete one of them, see that that works, and then go to the settings and delete all. and see that that works. So we can select either property here. The one fit for deletion, we'll create the first one that we created, we'll delete that one. So that properly deleted. Now we'll go back, we'll check the settings. We can reset all data here. Click reset. And now we see that it's been deleted. So that's everything that we've done. We've created the contract and we've deployed it. We've called it from Unity to do 3 different things: minting one property, deleting one property, and deleting all the properties. That's it. The project is complete. Now you can level up your Web3 development skills by building weekly projects. With Moralis.io/projects, you'll be able to build weekly projects, often launched on the weekends, win NFTs for your participation. Now, if this type of web content is exciting for you, like and subscribe to videos so you won't miss out on other free content in the future. Let's recap what we've learned today. So Moralis offers an SDK specifically for Unity that allows you to bring the best of Web3 into the Unity game engine. We see that sample game projects are complete experiences and they're a great way to learn Moralis functionality. This sample project allows us to explore a map and also to interact with contracts to do buying and selling of properties. The game showcases Unity features as well as Moralis features. Thanks for your time today. I hope you've learned a lot about Moralis, integrating with Unity, and what we can do with contracts inside of a game like the SimCity Web3 experience. Visit docs.moralis.io to download and get started today.